I'm a developer advocate for the Google Cloud Platform. So we understand our job as like as a bi-directional job between developers that build on our platform and the developers that build the platform inside the company, right? So please, please, please feel free to reach out to me. You see my Twitter handle up there. If you have like awesome projects and you want to talk about those and show them to us, please reach out. If you have constructive feedback, same thing. We want to make our products better. Fun fact, actually, as I just noticed, the percentage of German speakers is actually pretty high here in at DevFest Georgia, which is pretty amazing, and especially also the ones from East Germany is more than one. So when I'm not talking, I'm doing usually things like that. So I'm traveling a lot. So for me, it's amazing to be able to come to DevFests all over the world and speak and explore the country and the cultures in these areas. All right, so before I start, I want to get a little bit to know who's in front of me. So Daniel asked already who knows Kubernetes. I'm not going to ask that again. Who is a Java developer here? All right, we have a couple of Java. Golang? Golang? Nobody? Okay, number one. JavaScript? Web developer? Android? All right, we have almost the room covered. Amazing. Cool, so basically my job is really talk to developers and practitioners, so technical practitioners is my main job, so this seems to be the right audience. All right, so what am I gonna talk today about? So with my roughly 15 years of experience in software development, I created this beautiful app with a colleague, right? So state of the art, very simplistic color scheme, rough edges, beautiful, right? So this is basically my guestbook application. What you have here is you have a create, the guestbook service that receives the create of a message. You have a guestbook service that retrieves all or lists all your messages that you have in your guestbook, and then you have a little hello world service that basically shows you which server has answered or which pod has answered. So if we put that in a little bit more beautiful graph, we see this amazing application. We put that in a really complicated microservices architecture. So you have the UI that is running, that is talking to the Hello World service and the guestbook service, and then we have Redis for our session management, and we have a MySQL for our persistence. So none of the guestbook messages get lost, right? All right, so let's have a look at it, how this looks like. So to show you how that looks like is I have here a visualizer, which is called GCP Visualizer, and I'm going to give you the link afterwards. So basically what you have here is it shows you what my resource pool is. At the top you see the 4 nodes that I have, my Kubernetes nodes where I can schedule pods on, and then you talked about what pods are, what deployments are. So I have right here, you see my pods that are running. I have a deployment which controls these pods. Okay, this deployment says basically I want to have 2 pods. So these are the 2 pods that are running here. And then I have a service which is basically routing traffic to these pods. So never speak to a pod directly. Also, they have IP addresses. Never speak to them directly. Always use the service to talk to them. So as you can see there, I have 2 IP addresses. One is my internal cluster IP address. So this is the one that pods and services can talk to each other basically inside the cluster. And then I have another one which is an external IP address. So you see here my application comes up. It's a Spring Boot application, as we can see up here, right? So let's see. Whoa, all right. Hard refresh, right? Demo fail. All right, who didn't want to see me failing in the demo? Nobody? Everybody want to see me failing? All right. All right, so what do we have here? I have roughly 25 minutes left. I'm just going to debug this right in front of you, all right? Everybody with me? Awesome. Okay, so what do we have here? We have an amazing white label error page. Couldn't it be more beautiful? What does it tell us? So please, please, please don't use white label error pages. They are horrible. But we have here, it tells us yeah, that's today. We saw an unexpected error, internal server error 500, 404, and null. So there's only one thing for sure that we know here. It's a Java application, right? Null pointer exception, null Java expectation, all right? But there are multiple errors in here. So what would you do in a production environment if you get something like this, right? Nobody actually deploys application unless it went through like testing and QA and staging, right? So we should have maybe, hopefully, have like some staging over here. So in Kubernetes, what you can do something like kubectl get pods, which is basically all the pods that are running here in my cluster. If the Wi-Fi holds up and is loyal with me, okay. What you also have is something called namespaces. And so the namespaces are basically environments that you can set up inside of Kubernetes, which are basically isolated into some sense. They are not network isolated, but they're configurational isolated. So what helps that to you is like if you have any kind of configuration files. So let me see if I'm here in the Spring Boot Docker, for instance, example Java, and then Kubernetes. And then I have here, for instance, some configuration files. So let's have a look in our Hello World deployment. So this is how like these configuration files look like. And Daniel showed a little bit of this. And it basically tells you what it should be running, what it's connecting to, what kind of containers you're running, and all these things, which is great. So basically, they show you all the things that are running, and you can use these configuration files and take them and just deploy them to a new like environment, a new namespace. So that helps you to have like multiple of the complete application environments running in one Kubernetes cluster. So I have, of course, my application running in my staging as well. So let's have staging and let's say servers and pods. So I'm getting here like my services and my pods, and I'm seeing there I have my Hello World UI running in staging. This has this IP address. So let's have a look at this. Let's see if this is a different IP address. Looks like a different, voila, application runs, all right? So at least this demo didn't fail. So let's see if the service is actually running. And my finger game is not good today. So you see, like it stays in my guest book. All right, so what now? So my staging is running, my prod is not. So what do you do now? You, of course, compare, like, is actually the same thing running in prod as in staging? So how can we find out? So what we can do in Kubernetes, we can actually describe a pod. So I describe my pod in production, and I see all the things that are basically in there. So all the environment variables that are set, the CPU that I requested that I got, how many restarts I have. And we also see up here the image that got loaded. And you see there, Hello World latest. Latest, really? Never, never, never use latest as a tag, as a version tag. Really bad, because you latest, basically you override this and you don't really know what's behind this latest tag. Always use immutable version numbers for your containers and deploy immutable version numbers. So call it v1, v2, v3, v4, and then you know, if you look at these things that you have deployed in your staging and in your production environment, you actually know if these are the same things that are running there. At least this is an indicator for it. So since we have only latest running there, we need to resort to something else. And what's nice, we get actually an image ID with SHA, basically, with a hash. So since you're all here, and I hope you can read these numbers, so I'm going to remember the first, let's say, 5, and you all remember the rest, okay? And then we compare the ones that we have in production and in staging. Everybody memorized? All right, cool. So let's do kubectl describe, and then let's do the staging, and we have here the staging. We see AD231, that looks right. Everything else correct, right? Okay, awesome. Cool, all right, so, okay, the same container is running in the deployment, so both have the same environment, so what now? So the next thing that you want to do is, okay, I need to dig deeper. I need to get more insights. So let's imagine you have like a traditional application system where you have deployed an application. What do, right? You go and log into the server, you pull down some log files, and then you unpack them on your machine, and you look and whatnot. So Kubernetes actually has a really nice feature which can give you logs for, so I can do kubectl logs, and then I can do hello world, UI, and then one of my containers, and it basically just shows me my logs. And amazing here, it shows me all these arrows, so I actually hit the right one. Cool. And you see, like, this runs through like a matrix, right? So it's really hard to pinpoint. Now, I didn't show that earlier, but what I actually have is I have multiple pods running, right? Right now, if you see here, I actually have 2 pods running. So the chance that I actually hit the right pod where the arrow is happening was like 50-50%, right? So what do you do if you actually do something like this, and suddenly you have 10 pods, right? So right now I just scaled my application, my UI, to 10 pods, and they will be coming up. So if I do this again, you will see that they are now all running. Amazing. Now what is the probability that I find the pod with the error? Still 50%, right? You either find it or you don't. So, all right, of course you don't want to log in and stream every single one of those and check it. Like, what you can use there are a couple of open source tools that you can use to aggregate actually logs in Kubernetes. So you have Hello World, so kubetail is one of those, Stern is another open source tool that you can use, and you basically just use kubetail, you give it the deployment, it will find all the pods that are responsible for this, and then let's see, now if I go to my application and it will look like this, right? So again, we have this matrix, right? And it's really hard. At some point, your buffer in your client and in your bash basically runs out, and your shell runs out, right? And then the arrow is gone. So you need actually some other ways to inspect your logs. So what you do in Kubernetes actually, if you run on GKE, but also if you build on your on-premise clusters, always have like some log agents installed. In GKE, this is installed by default, and it will actually collect all the logs for you into a centralized logging system. So this could be an ELK stack, right? Elasticsearch, Logstash, and Kibana. Since I'm working for Google, I have that all as a service provided to me. So what we have here is I can actually go to logging, and then I can select my cluster here. So I have down here the container cluster. This is my guestbook cluster that I have here, and then missed it. I have all my namespaces that you see down there. And then, so since this is the default namespace, and then I can actually drill down and basically say, like, okay, I only want to see the Hello World UI ones. And then you see all the errors here, and I can click on each of those and can look into those. All right, so I now have my information. They are centralized in one system for all the pods that you're running, which is nice. But now imagine you get paged at 3 a.m. in the morning, right? And there's an error in your system. What do you want to do? Like, you either try to stay up and work through the night and try to fix this, or you look first if this is actually something contained, right? So, but now how do you find out if this is something contained? If this is maybe just one pod and then you just kill the pod, right? No, don't kill the pod, and I will tell you why later. But, so you actually want to get some analytics around this. So the nice thing is what you actually can do is you can export your logs into different kind of services. So BigQuery is one, which is our data warehouse service, but you can also export it to Cloud Storage or Cloud PubSub. So Cloud PubSub, if you want to do, is our message bus system, if you want to do real-time analytics on it. Now, I have this already exported to BigQuery, and so what I can do with BigQuery now is I can actually check if this is something contained to one server. So what you see here, I hope it's readable. I tried to make it a little bigger, but I can't see it anymore. Is this readable from the back? From here, I can hardly read it. All right. So basically, I'm trying to explain it. What you do here, like all these logs get actually exported into a table on BigQuery. So you see here we have our data sets, GKE playground logs, and then our tables with Hello World UI. And then they are partitioned by day. And then they have things like all the things that you see here, like the log name, the resource, the types, the container, all kinds of information are actually in this relational schema in BigQuery. And that enables me to do queries over it and do analytics over it. So right here, what I'm doing is basically I'm doing some filtering on the container, on my Hello World UI, and on the payload exception. So I only want to look at the exceptions in my logs. And then I'm grouping that by name and occurrences, and then basically selecting the occurrences and the pod ID to see like if this is a very contained error. So now, since we have done this here, you see, let's see if I can do this. You see now here I have like this one container that's there, and it has like 88 errors. So it seems like this is kind of like a contained error, right? So what I can do now is I can actually take this out of the serving pass. So Daniel explained about labels. So when you have with labels, you can basically tag any API object in Kubernetes, and by that you have basically a way to have the deployments know which pods to serve watch, and which services have to like route traffic to which kinds of pods. So what I can do now is, and we can see this right in here, if I do Kubisi get pods L serving, it basically shows me all the pods with the serving label. And this serving label is basically what the deployment looks for and says like, okay, and this is the pods that I have to control. And it's also the service which looks for that it's only routing traffic to pods that have this serving label. So now what I can do is actually, I can take this out of the serving pass and just change this label to false. So right now, what we can see here, if I do get per serving, I see we have this one that is false. And there's also something that I want to point out is like we have one pod here which is only 5 seconds old. And that is actually the new pod that was created by the deployment, because suddenly the deployment saw, oh, I only have 9 pods left, I need 10, so let's start a new one that I serve again from 10 pods. Now, the cool thing is what I can do is now I've taken this out of the traffic. So now I can actually inspect and be a detective into this pod, right? It's not getting any user traffic anymore. So I actually can look into this. So what I'm doing here is a port forwarding, and it's really cool. Like, there are a lot of powerful tools in Kubernetes. With the port forwarding, you can actually route traffic from your local host, from your local machine, to this pod, and Kubernetes takes care of all the authentication and everything for you. So now I have this pod, and let's have a look at my local host. So basically what I did now, I'm like isolated this container, and as you can see here, it's still working, right? I can still try and say, oh, my laptop is, all right, okay. I'm still Robert, and let's say hello, and I have a little bit of a lag in here. Yes. All right, so we see it's still working. So this is this pod that I took out of the serving pass for customers, but it's still working for me when I basically do port for routing directly to it. All right, so we have done like logs, we have looked into this, we have checked if the same things were. So now what we do, right? We need to get more insights into that. I need to find out like what is actually happening. So one thing that you can do on Kubernetes is, and that comes also with, for instance, Istio that was talked about earlier, is you can actually get some insights into what traffic is going on into in your application. So what I'm doing here is I have deployed something that inspects the network communication on the network level in Kubernetes. It's something called vscope, that you can actually just deploy to your Kubernetes cluster, and then it will inspect all your traffic in the Kubernetes cluster. So now with vscope, I can actually go and look at my traffic. So you see here, fingers crossed, yeah, it's still working. Let's try this. Come on. Let's make this a little smaller and a little bigger here. So basically what you see now is that you can see that there is some applications running, like there are these pods running, and when I now go to my application and just do this a couple of times, what you will see in vscope, fingers crossed, is that there will be lines coming up. So now you see, okay, like communication, network communication between my services is working. Now you could potentially see here, if there's no connection even going to one of your services, you would see this on this level. Now, I've demonstrated here, you can see it a little bit, that actually application communication is happening. There is like, but I don't have a higher level insights. I don't know like which request caused which communication between the services, right? I need a little bit more higher level insights into what my application is doing. And that's where tracing comes in. So then you talked also a little bit about tracing, and I'm going to show this really quick here. With tracing, basically what you do is, back in the days, what you did is you had to basically look at your maybe request headers, you like put them in artificially in your application code, and then you went through your logs and pulled all the communication or all the things, all the request responses out of your logs and put them together and to see like what request caused which kind of error. Now with tracing, this is much easier nowadays. Nowadays you basically just include a library and you point it to a system where all this tracing data goes to. You point like how much do you want to trace actually of your application code. Like usually you use a probability, like I want to have like every 1,000 requests or every 100 requests traced. And all this data basically goes to a centralized system again. Now since, again, I'm working for Google Cloud, I can actually use our tracing system. So what you have here now is basically, it gives you some insights into like, okay, what's like the latency distribution over your requests. And I also can go into individual traces of my application. So you see here we have a couple of these application traces. And I can go here and then I can basically see, okay, this is arrow 500, amazing. So we actually saw like this is where the arrow 500 comes from. And then it trickles down, you basically get a waterfall of like which services were called in which kind of sequence and what kind of time were spent in each of these services, right? So you can actually pinpoint if a service uses up a lot of your request time. And all at the end, you can see actually that we have here our 404. So that is where our 404 comes from. Now we can basically go to the service and actually look like what is happening in this service that causes the 404. And that's what I'm going to do next. But now imagine you would have to do this in a production system, right? You have your application code deployed. Let's even say you use Kubernetes. You have it in your containers. Now here in the round, like who can deploy to a production system within, let's say, 2 hours? Who can deploy to a production system within a day? Let's say a week? Is nobody deploying the production code? Who is deploying production code? All right, we have a couple. How long does it take for you to deploy the production? Couple hours? Days? Days? All right. So imagine it takes you a couple of days to deploy something to production, right? By then, your customers are gone, right? Or your business is really angry at you. So you need to have some like faster way to actually find out what's going on in your production system to debug this, find the error, and actually deploy a fix. Now, there's like some, like, how would you do actually the debugging, even if you have a couple of days? You wanted to add actually some, let's say log output, right? Some more logs that you can inspect. So what you do is you pull down your application code, find that's the right version that is actually running in production right now. You add your log statements, then you go through the entire like build pipeline, CI/CD, and then you deploy it to your production system. Now, where are we at then is like a couple days later you have it maybe a little bit more log output, but maybe you realize, oh, this wasn't the right one, I need actually more. So we have something pretty cool in Google Cloud, and that I have to say, like all the other things that I showed so far, there are open source systems out there that can provide you this functionality. This is something that you actually have to run on Google Cloud. But so how can you do this? So here I actually linked my source code that I'm running for my guestbook application to my Stackdriver debug application that I have here. And what I can do is I can actually add log points directly in my production code. So let's see. Let's say, how do you debug usually? I have to admit, I'm a really bad debugger in that sense. For the longest time, the way that I debugged was, I'm here. And then I was like, all right, 2, this was successful. right? And then you were looking for this in your logs, right? And then maybe, because we are fancy today, let's do 1.5, which I added later. My name is, and now we put a name here and add this. Now, this is actually going directly into my production code. Now I can basically, let's say, I can reload this a couple of times. I can go back to my logs. And then we go to our Hello World UI. And we say, OK. And then as you can see here, we have a couple of informations. Let's see. I might have to make that a little smaller that we see here. All right, 1.5. Right, my name is, and my name is empty. Oh, my name is empty. So this is the bug. All right. So as you can see, like with this log output, I actually could like inject log statements into my production code and directly show them in my logs without having to redeploy anything. So that is very powerful, but some might say, like, I don't like the print line out debugging. I want to actually have a stack trace, and I want to have a real debugger attached to it. So who is attaching a debugger in production? Nobody, right? Even though it sounds amazing, because it probably means job security for you. Every time like your customer runs into your debugger, you get called. It's like, hey, Robert, can you step through the debugger? We have a customer, right? Not really good, not really good. So what you want to do is actually you want to have a non-blocking like attached debugger, and that's something that we can do again also with stack driver debugging. So what I have here, again, we have our source code here, and I have the snapshot function here on the right. And now let me make this a little bigger. Nope, that was the wrong direction. So now we have this snapshot function, and now what I can do is I can actually attach a snapshot. And as you can see down there, it is waiting for the snapshot. So let me try to organize this in a way that you can actually see how this snapshot is coming up. So I have here my web page. You see still it's waiting for the snapshot. I'm reloading, and yay! All right. So now you have this snapshot. You see everything basically what is happening at that point. You get the call stack. You get the variables that are like what values they are having. Everything, right? And it's non-blocking, as you saw. I still got my response page back. So this is a non-blocking attachment of a debugger to your production system, which enables you very powerful debugging. All right. So let's recap. Logging, like first of all, in Kubernetes, always log to standard out, standard error, so that you can actually collect that in a centralized logging system. You can actually inspect that in the centralized logging, and then you can also do analytics over it. Number two, tracing. Like for observability, to get insights, higher level insights, and how your microservice application is actually working, where like what times are spent where, and how like actually which service calls which, like how that all works. You do tracing. So usually it's just as simple as like adding a library to your application. So if you have, for instance, Spring Boot, using Spring Boot for building your application, you can just add a library, Spring Boot Sluice, and then you have that collected in Stackdriver or like in your Jaeger or something like that. And number three, debugging. So basically, if you want to do things like live debugging on your production, that is something where Stackdriver has some special tools for you, where you can actually do log messages indirectly into your production, running production code, and also even get stack traces right there. I want to give credit for this talk. It was not actually originally built by me. It was originally built by my colleague, Ray Theng, who is very strong in the Spring Boot and Java community. I've done that talk with him a couple of times. It's a little bit more dynamic if you do that with a co-speaker. Unfortunately, he couldn't join me today here, so I did that myself. But please also feel free to follow him on Twitter if you have any questions around this whole Stackdriver debugging and debugging and troubleshooting in Kubernetes. With that, thank you very much for your time, and I hope you enjoyed it. Questions? I think we might have 5 minutes, and then we only run over 30 minutes for yeah.
Hey, thanks for the great talk. Can you talk more about how does this debugging work? Because it sounds like magic. And does it work for different languages as well, or it's just JVM?
So it does work for different languages. You can look at on our Stackdriver page. The way that we do it for Java is basically when you start your Java application, you attach an agent to the JVM, right? So basically you start your Java application with a little string which tells okay, please use this agent, and that agent is set up to do all the communication with Stackdriver for the live print line statements or log statements, as well as the snapshot stack tracing.
And would you run it in production? Doesn't it have overhead?
So the overhead is very little. So we actually run that at Google for our applications in production. We use that technology. The overhead is in a very low single-digit percentage range, and it's non-blocking. Yeah.
Does this magic supported for Node.js or only for Java?
I would have to check if we have it for Node.js as well. Please check on the web page. But we have it for Golang, Python, Java, and then my memory doesn't serve me very well. But it might be that we have something for Node.js as well. But please check on the web page for the definite answer for that.